All right, hey, picking up with the second half of the study guide for Unit 1. Let's see here. Cool. All right, the last multiple choice one I don't think I got a chance to go over. So after having a bad day, your mom tells you to have a z-score of positive 2.2 today. What does that tell you? What does that mean? So any z-score tells you how many standard deviations above the mean. So that would be telling you have a day that's 2 standard deviations above the mean. It's just one of those exceptional days where you do that much better. So it does not mean below average. B is the perfect answer. Does not tell you what the standard deviation is. And D is another good answer. It means that your mom is a total nerd, but good-hearted. That was supposed to be good-hearted. Your mom is a total nerd, but good-hearted. Don't choose this one. And you will have a day that is 2.2 times as good as the last. It's also a wrong interpretation. For real, B is the one that you'll want to know for that. All right, now on to the free response. Your free response, your test is going to have a couple free responses. I want to say 4 or 5, so this should get you ready for those. The table shows, this is a frequency table, how many, not relative frequency, which shows percents. We're going to make those. The table shows different students, preferred streaming media provider, and gender. So I made the totals there. 20 people said Netflix, broken down 8 males and 12 females. There was a total of 37 males and 24 females, altogether 61 people. You'll notice I have these little scrunched up areas because there's just a lot of writing. So what's the marginal distribution? You need to remember marginal distribution deals with the margins. So this 20 out of 61 came from this 20 total, the 20 people that said Netflix out of 61 people total, or about 32.7% answered Netflix, 28.7% answered Hulu, 26.7% said Sling, and YouTube TV was a small 13%. So that means you need to know marginal distribution is talking about the totals, the margins of the graph. Conditional distribution is when you break it up male versus female. And conditional distribution amongst males, I already did that for you. Netflix, 8 out of 37, or right here, the 8 out of total 37 males, 21.6%. Hulu, 11 out of 37, 29.7%. Sling, about 32%. YouTube TV, about 16%. What kind of display could you use? What display could you use to display the association between gender and streaming options? Something like a pie chart would work. Or stat bar good. So that you would be able to compare. B, compare your answers with B with the conditional distribution of females, which I gave you below. Is streaming opinion independent of gender? So remember, if they're different, they're dependent on gender. If they're independent, you would be seeing something along the same lines. So just hypothetically, if it says 50% of females said Netflix, then, and hypothetically, if 50% of males said Netflix, then your streaming option would be independent of gender, because just no matter what, you would have had about 50%. Now, that's not what we see once we actually start comparing these, getting males on screen here. So Netflix, about 21, whereas females were 50. Those are largely different. So your preference of Netflix depends on your gender. Hulu 25, Hulu 27, 29.7. That's pretty close. You might be able to infer that Hulu's option might be independent of gender. I have no idea why, but that just might be something. Sling 32, Sling 16.7 is not very close. Likewise, YouTube TV 16 to 8 is not very close. Probably say that the only one that might be independent of gender would be Hulu's option. The only stream that might be independent is Hulu, since they're both close to the same percent. The 5 number summaries for the number of followers on a teenager's Instagram is right here. So the minimum number of followers, 8. The 20 percentile, quartile 1, 894. The median number of followers on a teen's Instagram is 1,061. Q3, 1,245, and a maximum of almost 5,000 at 4,691. Are there any outliers in this data set? To find outliers is anything beyond 1.5 IQR. That means you have to have a high fence and a low fence. So high fence starts at quartile 3 plus 1.5 times IQR. The low fence starts at quartile 1 minus 1.5 IQR. That's your formula right there. Quartile 3 and making IQR quartile 3 minus quartile 1. I think I got that to be 1,771.5. If there's any values above that, those would be outliers. If you have a max that big, there are definitely some outliers on the high end. Check that out with the low fence. Throw that in the calculator. Quartile 1 minus the 1.5 IQR. I got 367.5. Look on the low end. There's definitely some low outliers there. Now, this doesn't tell you how many, because there could be a whole lot above the high fence and below the max. So there could be several outliers, but we know that there are some high and some low. On to 14. A class's summary statistics for a recent quiz are given below. What would the new statistics be if OC curved the quiz and added 10 to each score? This is asking if you know what happens when you, to a data set in the statistics, when you add 10 to everything. Well, is the mean affected? Yes, it is. 81, if the mean was 81 and I added 10 to everything, the mean is now 91. However, standard deviation measures spread. Spread is not affected by adding 10 to each score. So that standard deviation of 7 stays 7. Likewise, IQR is also a measure of spread. That 18 is still 18. Quartile 3 is a measure of position, so that 92 would be bumped up to 102. However, if I said what would the new statistics be if OC curved the quiz, and if I just said multiplied 10 to each score, well, then everything would have been affected. Looked up some actual stats. In the NBA 18-19 season, each team averaged about 18 points from free throws per game with a standard deviation of 2 points. Likewise, in the same year, they averaged 23 free throw attempts with a standard deviation of 3 free throw attempts. So this is talking two different things. In yellow, that's how many free throw attempts. In blue, it's how many points they got off of free throws. So how often does a typical team score less than 19 points? So this is points scored. You're using the data up there. I'm going to ask a z-score, even though you might not need it. So z is what happens in the problem, 19 minus the mean 18 over standard deviation 2. Your z-score is 1/2. To put things into perspective, here's average, here's above average, you're right in between, you're shading less, so you should have precisely 69.15%. How often does a team attempt more than 26 free throws? Well, this is a yellow one because it wants to know a reference how many free throws, not how many points. This says more than, which is why you're shading right. Question asked 26, should probably be yellow. 26 minus the mean over standard deviation, your z-score is 1. Getting 1 percentage over 1 would be 15. I'm going to hurry up and just show the answer here. Use a calculator to find CF in between these two and inverse normal on the bottom one.